Okay, let's just get started with logic gates. Last time we have learned this already, which is propositional logic that deals with propositions and logical relationship between them. And this one is a form of the propositional logics that creates a new proposition from existing proposition. So what are the propositions? Again, their statement that is either true or false. Like 1 plus 1 equal to 2 is a true proposition. 1 plus 1 equal to 4 is a false proposition. And go out is not a proposition. Red color is beautiful is not a proposition. So again, one proposition is represented by one bit, and that one is how it's related. Now, we also said logical operators, relationships are the logical operators used to manipulate propositions. And why do we have to manipulate them? It's actually combining them. And important is to create a new compound proposition, and that one is a new knowledge that we want. And we'll say why, because our computer, we don't just represent data, we want to do computation like addition and division, and so we need to combine bits in order to get a new bit. That one is to generate new knowledge. So there are logical operators that we have learned, like the NOT operator, AND operator, OR operator, exclusive operator, and biconditional operators. The question right now that we are learning is, how can we use physical components in order to build this, to implement these operators? And these are called logic gates. Okay? So before that, we'll just give some terminologies, review terminologies that we have done actually. So the logical operators are the relationships that we have learned, and the form of the compound proposition equal to propositions, and combination of relationships like this is called Boolean equations. Okay, so we'll see again. We'll have some terminologies first. Boolean equation is the form of creating new compound proposition from existing propositions. The next one is logic operators are the relationships, okay, or the operators. Then right now we also have one more terminologies that we learned earlier, which is the truth table. So the truth table is actually for every combination or possible combination of all the propositions, what is the output for that? Okay, so let's say true for this, then true for that, then false for other things, then true for this. What is the output of the compound? So what is the new knowledge? And this one is called the truth table. Formally, it is least truth values for compound proposition for all combinations of its components. This one is what we learned last time. Now we'll say logic gates. Okay, it deals with logical operators that act on proposition to get new compound proposition. Then we'll learn that logic gates is actually simple, I think the simplest digital circuit. Okay, the simple digital circuit to implement logical operators. Okay, so if you have one operators, there is one gate that implement that. Okay, and it's take one or more inputs and produce one output. That one is logic gate. So the term circuit over here, it is a circuit, which means that it can be built using transistor. Okay, this one logic gate can be built using transistors, and that one is the physical component. And how to build one? If you want to learn how a transistor works, we do not focus on that level here. But if you want to know how a transistor works, it is good to refer to these two links. Okay, so in this case, we're going to learn the following gate. We'll learn the NOT gate. We're going to learn the buffer gate. We'll learn the AND gate. We'll learn the OR gate. We'll learn the XOR gate. You will learn the NAND gate. You'll learn the NOR gate, and you'll learn the XNOR gate. So you already learned the NOT operators. This gate is to implement the NOT operators. This gate is to implement the buffer operators. This gate is to implement the AND operator. This gate is to implement the OR operators, so on and so forth. Okay, so if you have logical operator and you wanna physically implement it in computer, you're going to use logic gates. And all say, so how do I have the logic gates? They are physical components, and there are manufacturers who sell this for us already. Okay, and they build based on transistor. Okay. So this gate have multiple inputs, can have multiple inputs. So normally we'll learn with one input or two inputs and one output, but we can have gates with multiple inputs as well. We'll learn them later. Okay. Then in the next section, we'll continue to learn with all of each of this one gates and what do they do.